In this video, we're going to go through number 27 of mastering, which is actually one of the bonus questions, but I want to go through and give you some guide and helpful information as to how to solve each of these types of problems. Now, your numbers might be different than mine. I highlighted my information, so you can just double check what your information is. Go through the same process, but just know that your answer will probably be different. So for part A, it says give the mass of the solute and the volume of the solvent for 1.30 liters of 0.120 molar ammonium sulfate. So we need to figure out what mass of solute and what volume of solvent we would need to make 1.3 liters of 0.120 molar solution. So let's focus on molarity. So remember that molarity is moles of solute over liters of solution. So moles of solute over liters of solution. So I'm just going to plug in my information and I'm going to solve for solute. So 0.120 molar is X moles over 1.30 liters of solution. And I'll go ahead and I'll plug this into my calculator. 0.120 times 1.3, so 0.156. X is 0.156 moles of solute. Remember, my solute is this ammonium sulfate. My solvent is most likely water. So notice though it wants mass of solute and volume of solvent. So I need grams and probably liters. So I need to take my moles of solute and I need to convert it to grams. So 0.156 moles. I'll calculate the molar mass of ammonium sulfate. Molar mass of ammonium sulfate is 132.2 grams per mole. So if I do 0.156 times 132.2, we get 20.6 grams of solute. And then it also wants volume of solvent. So more than likely, since they didn't give us any other information, our volume of solvent will be 1.30 liters. So in mastering, you'll do 20.6, comma, 1.3. So for part B, this one's a little bit more complicated because we have to really use the information given and solve for some different variables. So part B says give the mass of the solute and mass of the solvent for 220 grams of a solution that is 0.65 molal sodium carbonate. So they give us the mass of the total solution and they give us the molality. So they don't even give us information that we could use to go from solution to solvent or solute. So we're going to start with the molality, and we're going to actually write out what this molality would mean. So if we have a 0.65 molal solution, that means that we have 0.65 moles of solute, which is Na2CO3, in 1 kilogram of solvent. That's what that means. We have 0.65 moles of sodium carbonate in 1 kilogram of solvent. So let's take each of these and let's go to the same unit. So let's go to grams. So I'm going to take 0.65 moles of sodium carbonate and I'm going to go to grams. Molar mass of sodium carbonate is 106 grams per mole. And so if I take my calculator, 0.65 times 106 gives us 68.9 grams of Na2CO3. So I have 68.9 grams of Na2CO3. 1 kilogram of solvent. So again, our universal solvent is water, so this is more than likely water. Think about kilograms and what that means in grams. So remember that 1 kilogram equals 1,000 grams. So what this means is that I have 68.9 grams of Na2CO3 in 1,000 grams of water. I just took molality and I just converted to the same unit. Now it's not the same substance, but it's the same unit. So based on this now, here's my solute, here's my solvent. Now, this is not 220 grams of a solution right now, because what this is that if it's 68.9 grams of Na2CO3 and 1,000 grams of water, this actually is going to give us total mass to be 68.9 plus 1,000. It's going to give us a total mass of 1,068.9 grams. So let's try to figure something out. If I have 68.9 grams of Na2CO3 in 1,068.9 grams of solution, how many grams of Na2CO3 would I have in 220 grams of solution? So let's just set up a proportion. Try to figure out what this new amount would be. So I'm just setting up a proportion to say, okay, well, this is based on molality. This is how much solute we would have per solution, but if we change the amount of solution, what would we have? So remember, to solve for a proportion, we cross multiply. So 68.9 times 220 divided by 1,068.9. Oh, I added an extra 9 in here. 1,068.9 gives us 14.18. So it gives us 14.18 grams of Na2CO3. So here's my solute. Well, if this is my solute, I can figure out my solvent because here's my total amount of solution. So 220 minus the solute gives us 205.82 grams of solvent. Oh, now 3 sig figs. Okay, so I need to redo this for 3 sig figs. So 3 sig figs for the solute would be 14.2 grams. 3 sig figs for solvent would be 206 grams. Okay, so now we're going to take a look at part C. So part C says give the mass of the solute and mass of the solvent for 1.3 liters of a solution that is 15% lead 2 nitrate by mass, and they give us the density of the solution. So we have the total volume of the solution, and we have percent by mass. Well, remember, percent by mass is mass of solute. So this would be mass of PbNO3 over total mass of solution. So in order to use percent by mass, I need to know the mass of solution. So I have volume of solution and I have density. So let's start by using that information to find mass of solution. So remember, there are 1,000 milliliters in 1 liter. And the density says that for every 1 milliliter of this solution, it's 1.16 grams. So if I solve this, 1,508 grams of solution. So there's my total solution. So we can use this to find mass of our solute. So 15% is 0.15 is our mass of solute over total mass of solution. So all I did is, instead of doing times 100 over here, I already divided it out. So 0.15 times 1508, 226, so 3 sig figs, 226 grams of PbNO3 2. So there's my solute. That's what we're going to list first. So if that's my mass of solute, here's my total mass of solution. You can subtract them. 1508 minus 226 gives us 1282 for our solvent, but again 3 sig figs, 1,280 grams of solvent. So again, in order to use percent by mass, we needed to know the total mass of the solution. So finally, part D, give the volume of the solute and volume of the solvent. So both of our answers are going to be in volumes. For a 0.50 molar solution of HCl, that would neutralize 5 grams of barium hydroxide starting with 6 molar HCl. So this one's a little bit more complicated because notice we have 2 amounts of HCl. So I'm focusing on 0.5 molar HCl neutralizing 5 grams of barium hydroxide. Neutralizing means stoic. So I'm going to start by writing out a balanced equation. Barium hydroxide plus HCl. This is an acid-base reaction. We get H2O, barium chloride, because barium is +2, chlorine is -1. So here's our balanced equation. Balanced equation is useful because, again, neutralization means stoichiometry. So I'm going to actually start with the mass. And I'm going to stoich 2 moles of HCl. So if I have 5 grams of barium hydroxide, how many moles of HCl would we need to neutralize that? So 5 grams of barium hydroxide. So let's go to moles. All right, always go to moles. Molar mass of barium hydroxide, 171 grams. Again, this is just molar mass, added it up. So I'm at moles of barium hydroxide. Now I'm doing stoich. I need to stoich from barium hydroxide to HCl. I need to know how many moles of HCl are required. So for every 1 mole of barium hydroxide, 2 moles of HCl is required. And I'm going to go ahead and solve. So 5 times 2 divided by 171, 0.05848 moles of HCl. So I went out to 4 sig figs. So this is the number of moles of HCl that are required. Here's the molarity of HCl that we have. Question wants volume. So, moles, molarity, lets me find volume. So a 0.50 molar solution is 0.05848 moles over X liters. So now to solve, I would multiply X over and divide by 0.5. So X is 0.117 liters. But if you look at the units on mastering, it wants milliliters. So 1 liter is 1,000 milliliters. So that is 117 milliliters. Now, it also wants 2 sig figs. So 2 sig figs would be 120 milliliters. So if you take a look at mastering, it says volume of 6 molar HCl and volume of 0.5 molar HCl. So this is going to be the volume of the 0.5 molar HCl. So this is the second value. Now notice that the first value is still HCl, but it's 6 molar. So if we have this volume of a 0.5 molar HCl solution, and we're starting with a 6 molar HCl solution, we're going from a higher concentration to a lower concentration of the same thing. That's dilution. So M1V1 equals M2V2. It doesn't matter which pairing you pick as which. I'm just going to do 0.5 molar, 120 milliliters, 6 molar times V2. Because this is in milliliters, this will be in milliliters. So 0.5 times 120 divided by 6. Now when you solve, so when you do 0.5 times 120 divided by 6, you get 10. That's only 1 sig fig, which means instead of using 120, I need to use 117. I need to use my unrounded value. So 0.5 times 117 divided by 6 gives me 9.75. So 9.75 milliliters is the volume of 6 molar HCl. So part D actually had us looking at stoic, using molarity, and using dilutions.